Welcome friends in the lecture series of antenna and wave propagation. Continuation to this, we are discussing in previous lecture the array of two isotropic point sources having equal amplitude and oscillating in same phase. In this lecture, we are discussing array of two isotropic point sources of equal amplitude, but opposite phases. Okay. So, in this lecture, the content is equal amplitude and opposite phase, and second we discuss any phase, because it is also important to discuss. Sometime the numerical is asked that the phase shift in 90 degree, 180 degree, 3 pi by 2 and so on. So, it is important to discuss this topic. So, starting with the first topic, array of two isotropic point source of equal amplitude, but opposite phases. So, if you recall from the previous knowledge that equal amplitude means the two sources radiating in a far field region having E 1 is equal to E naught and E 2 is equal to E naught, the amplitude, and same phase. Okay. But what are we here we considering? Out of phase, that means E 1 is equal to minus of E 2, or we can say that E 2 is equal to minus of E 1. Okay. So, this thing you need to understand, and the remaining process is similar as we discussed previous cases. So, let us begin with this. Here we consider two isotropic point sources having same amplitude E naught, okay, E naught having same amplitude E naught, and oscillating in opposite phases as we discuss here, and both are separated by a distance d. Okay. Now, first up what we have to do? We have to calculate or find out what is the path difference, and then we move to the calculation of phase difference. Path difference is the length travelled by electric magnetic field EM wave towards the point in far field. So, it is a length. So, there are two sources as we seen in earlier cases. So, both the path length are different. So, we find out, as in earlier case, the path difference is nothing but d cos phi, and the phase difference is 2 pi by lambda times of path difference. So, 2 pi lambda into path difference lead to beta d cos phi. So, same formula as we have discussed earlier in the case number 1, two isotropic point sources of equal amplitude and same phases. So, next we move on to this. Now, as we consider this d is equal to order of lambda by 2, as we discussed this earlier. So, as soon as we put this d is equal to lambda by 2 order, the spacing between two sources, if it is source 1, it is source number 2, and both are differentiated by d, which is we considering lambda by 2. Okay. So, the separation between 2 point sources of lambda by 2, and this the far field point where we considering or we are interested to evaluate the total or net electric field, which is sum of, which is actually vector sum of source 1 field and source 2 field. Okay. And rest is the same consideration, d is equal to lambda by 2. So, the total electric field at a large distance. Okay. So, how we can define it? Same procedure, Phasor diagram, if you remember, recall E 1, E 2, and this is the resultant E. Okay. This is E 1, this is E 2, but phase are out of phase. Okay. So, if you consider psi by 2, if you consider psi by 2. Okay. So, the net field, if you go on from this to region, is given by this resultant field. This diagram we already discussed. So, again I am discussing. So, next time we skip this. So, as soon as we simplify this, so what we happen? E naught e ki power plus j psi by 2, because it is positive, and from here negative, it is minus psi by 2. So, E naught e ki power plus j psi by 2, E naught e ki power minus j psi by 2. Now, the important thing, because of out of phase, because E 1 is equal to minus of E 2 or E 2 is equal to minus of E 1. So, this sign is replaced because E naught is the magnitude, but it is out of phase. So, minus sign came into the picture due to opposite phase. It is very easy to understand. If you put your finger like this, so it is the, suppose this is the front arm, and if we place mirror in front of this, so what happened? Phase change 180 degree, that is the mirror image case or out of phase case. Okay. So, this way the minus sum came into the picture, and we simplify this. How we will get it? Simply what we have to do? See, E is equal to what he mentioned here, we have to form some Euler identity in terms of sine and cosine. How we convert it? Using Euler concept, Euler identity. So, minus sign, as we know that sin theta is nothing but e की power j theta minus e की power sin theta by 2 e की power minus j theta by 2 divide by 2j. So, this is the formula. Now, we have to convert this. So, what we have required? We taken out E naught as a common and multiply and divide by 2j factor. If I multiply over here, what we have to do? We have to take E naught out from this, e की power j psi by 2 minus e की power minus j psi by 2. So, if I divide and multiply by 2j, so this particular is nothing but sin psi by 2 using Euler identity. So, we have replaced this whole expression and rewrite into this format. E is equal to 2j E naught e की power plus j psi by 2 minus this upon 2j, which is nothing but sin psi by 2. Okay. Please understand this, there is a two formulation, cosine and sine factor. Okay. So, this way we have decided and we have relate our expression in terms of Euler identity. So, our final expression, because psi is nothing but phase difference, and what is phase difference? From here pi cos phi, or we can say that if we do not want to change in this formulate, we can use beta d cos phi as self. So, here beta is nothing but wave propagation 2 pi by lambda, and d is the separation distance between two sources. So, this way we find formulate 2 j E naught sin pi by d cos phi. Now, what we have next to do? Normalize it with its maximum amplitude factor, and thus we normalize and we rewrite our expression by dividing the maximum value, or we can say that putting that value equal to 1. Okay. So, what we have get? Sin pi d by lambda into cos phi. Now, what is d? D is equal to lambda by 2. Okay. So, as soon as you put d is equal to lambda by 2 over here, what we will get? E n is equal to sin pi by lambda. So, lambda to lambda cancel out, what remaining? 2. So, pi by 2 cos phi. So, this way we simplify our expression into this terms, sine of something. So, again what we have to do? We have to plot this normalized field. We have to plot the radiation pattern or electric field pattern of this particular two sources having opposite phase. So, what we have to do? Again we have to find out the maxima point, then we have to find or locate minima point, and then at last we have to find out half power points, because we have to identify what is the half power beam width, first null beam width. Okay. So, this relation can be discussed in next slide. So, let us go to the maxima point evaluation. How we evaluate? Please remember what is our normalized field. Normalized field is sin pi by 2 cos phi. So, let us take it E normalized, which is sin pi by 2 cos phi. Okay. Maxima we discussed in maxima condition. So, sine or cosine takes maximum value of plus 1 or minus 1. So, plus minus 1. Now, you have to find out at which interval or which degree of sine its value is 1. So, at 0 sin 0 is nothing but 0, sin 90 it is 1. that is it is multiple of n pi. Okay. So, you can eliminate sign terms by replacing pi by 2 cos phi is equal to plus minus n pi. What is n? N is an integer whose value varying from 0, 1, 2, 3 and so on. So, again same scenario, let we discuss n is equal to, let we put n is equal to 0 here. So, what we have to do? Let n is equal to 0, because n is varying from 0, 1, 2, so on. Okay. So, we first case n is equal to 0. So, what is the value? Pi by 2 cos phi. As soon as you put 0, 0 of something multiple of something is again 0, or cos phi, because it is a maxima. So, every abbreviation is capital M, as we have discussed or taken similar as in earlier case. So, phi m max is equal to, or you can say that phi max also you can rewrite, it is up to you. Okay. So, 0. Now, when cos function is 0, just recall it, you know the answer. Cos 0 at, because cos 0 is 1 and cos 90 is equal to 0. So, this way you understand what is the maxima point. Okay. So, this way you can find out when you put this value is nothing but (180°), 0°, 2 points. Okay. So, this way we find out our relation of maxima, which is 0° and at 180° angle. At least we require 2 points. So, we can plot a symmetric pattern, because if you are looking for one plot, it is okay, upper half you can plot, but we require to plot a symmetric pattern in lower half also. So, we require 2 point at least. So, first point we have calculated 0° and 180°, this is the maxima. Next, minima. Okay. Again sin pi by 2 cos phi. Minima means, what is the minimum value of sin? It is 0, and when it is 0, sin 0 is equal to 0. Okay. So, how we relate it? Okay. Just one thing, we have confusion this, it is plus minus 1, it is not, it is multiple of, it is multiple of 2 n plus 1 pi by 2, because it is sine function, not cosine. I relate with cos. So, just change it, because sine is maximum at 90°. So, multiple of pi by 2, okay, and cos is multiple of pi, 0, pi, 2 pi, 3 pi and so on. So, over here when you put this value to n is equal to 0, what we have? Plus minus pi. Okay. So, plus minus pi by 2. So, just change it. Okay. So, plus minus 1, and that is the case. Okay. 0° cos 0, 1 cos at 180°, 1. So, this way this our answer is correct. And now, moving to this value. So, how it is? Again sin is eliminated when you consider pi by 2 cos phi is equal to plus minus n pi, because sin 0, sin pi, sin 2 pi, sin 3 pi and so on. Okay. So, this way we have to find out. Now, again what is the value of this? N is equal to, putting 0, what we will get? Cos phi minima small m, or you can write min. Okay. It is up to you. Cos phi min is equal to 0. Now, again you have to find out this answer. If you remember, the answer of phi min when you solve this is 90° and 270°. So, this way we have arrived at our minima point. Next, half power points. How we calculate it? As we know that the half power point is nothing but field is equal to 1 by root 2, and for power scenario it is 1 by 2. Okay. So, just equate it, sin pi by 2 cos phi is equal to 1 by root 2. This is the half power points, and as soon as you solve this problem, because multiple of 2 n plus 1 pi by 4. Okay. When you eliminate this, it will plus minus 2 n plus 1 pi by 4. Okay. So, again this sign is limited and this will eliminate, and same factor came over here. Okay. Now, again you have to simplify that, and at last we can compute phi half power point. Okay. So, the answer you know, when you calculate this for n is equal to 0, for n is equal to 0, we are solving this. So, we will get plus minus 60 degree, plus minus 120 degree. Okay. So, 3 this point, remember this, because with the help of this point we can plotting our radiation pattern. Okay. So, let me plot the field pattern of two isotropic point sources of same amplitude, but out of phase. So, again let first decide the coordinate. Okay. Again same scenario, this is y axis and here we considering x axis. Okay. Let me give the plot angle 0 degree, 90 degree, 270 degree, and sorry, this is 180 degree, 180 degree, 270 degree, and again 360. So, what is half power points? If you remember, phi max is 0 degree and 180 degree. So, somewhere over here first maximum occur at 0 degree and same maximum occur opposite, which is 180 degree. So, let mark this. Now, what is the minimum point we have calculated? It is 90 degree and 270 degree. Okay. 90 degree somewhere over here and somewhere over here, it is minimum, means the pattern is not existing at all. Minimum means side lobe, and the major power portion is in 0 degree and 180 degree. Okay. So, this is the maxima concept and this is the minima concept. Okay. And most important, what is the half power points? Plus minus 60 degree, plus minus 120 degree. So, let me draw the 60 point also, somewhere here 30, somewhere over here 60. So, this is 60 degree, okay, angle line, and over here 120 degree. Plus 60, then obviously it is minus 60, or we can say that how much it is, 330 degree. Okay. So, you can simplify it, and this is minus 120 degree. Okay. So, we have plotting. Let me change the color of pen. So, what we have, half power point at 60 degree, half power point, because this is the value where we have null over here and null over here. So, maximum peak value over here and peak value over here. So, what is the somewhere over here, half power points, plus minus 60, same plus minus 120. Okay. So, let me draw the pattern. It something look like this, and same because of symmetry in nature, 120 120. So, this is the radiation pattern of electric field pattern of array of two isotropic point sources having equal amplitude, but opposite phases. Now, if you compare this pattern to the previous case, that is same phase, what we have difference? Earlier we have maxima in direction of 90 and 270, because it is a cosine function, and now when it is changed from sine, it is changed to 0 and 180 degree. So, this is the only conversion in the radiation pattern of two isotropic point sources, and rest part is similar. And if we want to plot the half power point, is the value this is our half power beam width. So, what is 120 degree, okay, because 60 over here, 60 over here, total 120 degree. So, this is the radiation pattern or electric field pattern of array of two isotropic point sources. Okay. So, if we want to cover 360 degree, if we want to cover a 360 degree, so can we use this two combination, array of two equal sources same phase and array of two point sources with opposite phase, together it is 360 degree, okay, roughly 360 degree we can cover. And that is nowadays in scenario, if you visualize the mobile tower or BTS station, the dipole antenna are placed in 120 degree apart. So, 120 into 3 times 360. So, this way we can cover 360 direction. If one dipole cover 120, 120 and 120. So, this is called the sectoral dipole antenna or sectorization. Okay. So, this way we can draw the pattern. Now, here is the summary, same 120 half power bandwidth, it is maxima at 0 and 180 degree, minimum value, that is null, which is called null. Minima is nothing but null in direction of 90 degree and 270 degree. This is 270, this is 180 degree. So, this way we have plotted, and if you recall, our field pattern is nothing but same, normalized field pattern is E is equal to sin pi by 2 cos phi. So, same function we have discussed, and we can see that 60 degree 1 by root 2 half power points, maxima 0 1, minima 0, maxima 1, or sin 90 it is a 1, remember this, sin 90 maximum value, sin 0 minimum value, and half power points 60 degree, sin 60 is nothing but 1 by root 2. So, this is about all about opposite phases. Later we discuss any phase, because any application demand, or nowadays we have to consider all possibility, because you know we cannot say that only one direction, it may be for x case it is 90 degree, but in some cases it may be changed to 120 degree or 150 degree. So, we have to consider this scenario of any phases. So, again two isotropic point source situated at 1 and 2 having distance d, and from the center it is d by 2 d by 2. Okay. Here our far field point which we have to consider over here d sorry r, and the phi is the phase between this. So, again we have to find out electric field over here at far field. In a far field we have to find out what is the electric field. Okay. So, electric field, what, how do we calculate? Again we have to add this vector sum of point source 1 field and point 2 field, and together when we add up vector sum, that is the net, and then we have to normalize it, same scenario. So, again this is the simple relation, and you have to find out earlier what we have, the total phase difference, how much we are considering, beta d cos phi. Remember this? If you not remember, just go back to the slide. Beta d cos phi, for both cases we have considered, but here in scenario we have additional of any phase difference. So, what we have to do? We have to assume that factor, and how we consider it? It is additive in nature to that particular phase difference, because path length is same, but we have introduction of any phase which is additive to this, and how we consider it? Beta d cos phi plus some value, and this abbreviation let delta. So, let here the phase difference additive is this value, and we have represented over here. Rest of the scenario is similar, because the only change in is phase diagram, phase difference. So, now onward you have to consider the phase difference not only beta d cos phi, but beta d cos phi plus delta. Okay. So, this way you have to rewrite this again. So, again from point source 1 we have E naught e ki power minus j psi by 2, point source 2 we have E naught plus j psi by 2, okay. Same phase oscillating in same phase, point source 1, the case number 1, or we can say that for just previous case, that is opposite phase, how much it is. For opposite phase, this relation is only change E naught e ki power j psi by 2 minus e ki power minus E naught e ki power j psi by 2. The only change is this of phase. So, both way we can consider, but we are discussing the very first case, same phase, and again multiply and divide by 2 factor. So, what is our result? The total net electric field is nothing but twice of E naught into cos psi by 2. See, same scenario as in case number 1, there is nothing change at all this point, only change in this factor which is psi, only change in this factor. Earlier it is was beta d cos phi, now what is beta d cos phi plus gamma or delta, okay. Whatever you define, it is up to you. So, this way we have to again normalize, same process, and now we open by putting psi is equal to beta d cos phi plus gamma divided by 2. So, or we can rewrite beta is nothing but 2 pi by lambda, okay. Beta is nothing but 2 pi by lambda. So, this expression is how much? 2 pi by lambda, and what is d? D is order of lambda by 2 into lambda by 2 cos phi plus delta. So, lambda to lambda cancel, 2 to 2 cancel, how much remaining? Pi by 2 cos phi, pi by 2 cos phi and delta gamma by 2. So, this is our normalized field. Now, this is the general case of any phase difference. If suppose in question it is mentioning that a phase difference of 120 degree. So, what we have to do? Just put here 120 degree, or you can convert into radian, okay. Just convert it, or let me give you answer if it is pi by 4 phase quadrature, okay. So, what is the answer? Pi by 4 divided by 2, how much? Pi by 8. So, your expression of normalized electric field for phase quadrature is how much? Simply cos pi by 2 cos phi plus pi by 8. This is the resultant field, or we can say that pi by 2, then how much? Just add plus pi by 4 and so on. It is very easy. So, remember this formula, it is very important for defining phase difference, any phase difference, okay. So, let me summarize this. We started with same amplitude, same phase, then we go considering that one of the source lie into the origin. Again third scenario, opposite phase, amplitude are same, but opposite phase, okay. So, how we consider it? Opposite phase, the only change cos is now converted into sin because of minus came into the picture. So, according to Euler identity, we simplify and multiply and divide by 2 j. So, the net or resultant electric field is sin of something value, okay. And fourth case we have considered any phase difference. So, this way we simplify or approach to our final conclusion of any phase difference. E normalized pattern, field pattern is nothing but cos of pi by 2 times cos phi plus gamma by 2, okay. So, gamma can be any value, it is phase quadrature, it is pi by 2, it is pi by 6, it is pi by 8, whatever. So, just you put it and we will finalize our expression. Now, you can simply plot this. How we plot that? Again same scenario, when it is maxima, if you want to prove that, plot the pattern cos maxima plus minus 1. So, when it is maximum, cos 0 is equal to how much? 1. Cos 180 degree how much? 1. So, this way we have to find out, again same scenario. So, when you put this, we find our answer 90 degree and 270 degree scenario. Okay. Minima when this value is equal to 0, when 0 cos 90 degree. So, this way we can find out our relation or 2 points, and last half power points. How we find out? By putting power pattern 1 by root 2 times, sorry, field pattern, and remember for power pattern it is 1 by 2.5. So, this way we have found 3 point, minima case is equal to 0 and half power point 1 by root 2. So, this way we have to plot it. Okay. So, the pattern, whatever pattern we discuss when we discussing the next case, that is when the amplitude are different, because this is the scenario we have remaining. Now, phase we have discussed all about, we have discussed about pi by 4, pi by 8, pi by 16, whatever we require any phase difference, but only thing remaining in this continuation is different amplitude, E1 not equal to E2. So, we discuss into next lecture. Thank you.